Let's specifically take a look now at the inverse sine function, which can be written as sine with a -1 superscript or as arc sine. Okay, so we'll just do several examples here to motivate this idea. Of course, I'm assuming you're very familiar with the sine function and your 30, 60, 90 triangles and 45, 45, 90 triangles. That's going to help us understand these without the use of a calculator. So let's do some examples. Determine sine inverse of 1/2. Okay, so inverse trig functions output an angle, and the input is a ratio. And specifically, since this is a sine function, we know that this is the vertical side of our reference triangle. Okay, so if I look at my coordinate plane, my reference triangle has a positive vertical side. That means that my reference triangle could be in the first quadrant with the positive 1/2 reference, or positive 1/2 vertical side and a hypotenuse of 1. Or it could be in the second quadrant. Those are the two triangles that have a vertical side of 1/2. Anything in the bottom two quadrants will have a negative vertical side. So sine inverse of 1/2 also outputs an angle. So I've got to figure out which angle corresponds to this terminal side or which angle corresponds to this terminal side. I've got to pick one of those. Now here I'm going to choose the angle with the least amount of rotation. Okay, so if I'm looking at the terminal side in the first quadrant, the amount of rotation I need is this much rotation here. Whereas to get to the second terminal side, I'd have to rotate this much, which is too much. So I'm going to choose this angle to be the one I want. And if you recognize this as being a 30, 60, 90, then you know that this angle, the reference angle for this, I'll remind you of what it looks like over here, 1/2, 1, this is a 90, then this is a 30-degree reference angle, which means that this rotation here is 30 degrees, which is equal to pi/6 radians. So the amount of rotation we need to get a vertical side of 1/2 is pi/6. And the standard here with inverse trig functions is to output radians, not degrees. We'd like our outputs not to have a unit on them, and so we typically use radians. Okay, so if you type sine inverse of 1/2 into your calculator, in radians mode you should get pi/6. Let's do another example. Determine sine inverse of -2/2. So now, again, my vertical side equals -2/2. So if I draw a picture of that, my reference triangles now are going to be in the bottom two quadrants with a vertical side that is -2/2 and a hypotenuse of 1. And so I've got to pick which angle to use. Well, clearly this angle requires less rotation than this angle. Okay, so I'm looking for the angle in the fourth quadrant, and you should recognize this as a 45, 45, 90. So this is a 45-degree reference angle, and so I'm rotating in the negative direction. So sine inverse of -2/2 equals -45 degrees, or in radians, -pi/4. And that's the one angle that equals. Okay, let's keep going with some other examples here. Determine, and I'll use different notation this time, arc sine of 0. So now our vertical side is 0. And on the coordinate plane, if your vertical side is 0, you're either on the positive x-axis or the negative x-axis. And so I could either rotate nothing or I could rotate this much. Clearly, that's too big if I want to rotate the least amount, so I'll choose this angle, which has 0 rotation. So in other words, arc sine of 0 is the angle 0. No rotation gives me a vertical side of 0. Okay? Let's do another. Determine arc sine of -1. So now our vertical side is -1. Well, we know that working with a hypotenuse of 1, the most I could ever be from the origin is 1. So that means my vertical side of -1 would have to be on the negative y-axis. And so I could get, so that's the only angle. So I need to get there as quickly as possible, the least amount of rotation, so that would be this much rotation, as opposed to this much. That's too big. So, of course, that's in the negative direction, 90 degrees, which is the same thing as pi over 2. So arc sine of -1 equals negative pi over 2. Okay, let's do another. Determine sine inverse of 3. So now my vertical side is 3, positive. And I'm going to run through this like we're not noticing something, but if I have a positive vertical side of 3, that would look like this, or it would look like this. But in both cases I have a hypotenuse of 1. So hopefully what you realize now is that this is completely impossible, because how can the hypotenuse be less than the vertical side? The hypotenuse is the longest side. That's impossible. So sine inverse of 3 is not defined. It doesn't have an output. In fact, if you're going to take, so in fact, sine inverse of, let's say, r is only defined if that ratio r is between -1 and +1, since we're dealing with a hypotenuse of length 1. Okay, now there is another way to look at this, if you like. The other way to look at it is, if you have sine inverse of 3, you could think about this as being the opposite over the hypotenuse, since it's a sine ratio. So if you look at that, assuming the opposite side is the vertical side, then you'd have an opposite side of 3 and a hypotenuse of 1, because 3 divided by 1 is 3. And you have the same issue here, where the hypotenuse is smaller than the leg of the reference triangle. Okay, so there are several examples there with the sine inverse function. Now, in conclusion, let's make some observations or some conclusions. Let's say y equals sine inverse of x, okay, and we'll make some statements about y and x, the domain and the range. The first thing is, we already said it, the domain, the inputs for sine inverse, the domain of sine inverse is, well, x has to be between -1 and +1, okay? Now the more interesting part maybe is the range of sine inverse is, these are angles. What angles will it output? The outputs of the sine inverse function will always be between -pi/2 and +pi/2, because if you've got an angle that lives here or here, you're always going to choose this guy. You're never going to choose this guy. So those angles there are from -pi/2 up to 0. If you have an angle that has a vertical side that's positive, you're always going to choose this guy, not this guy. So these angles live between 0 and pi/2. So you're always going to choose an angle that lives between negative pi over 2 and positive pi over 2. You're never going to choose angles that live over here for sine inverse. Okay? So I'll do some other videos about inverse cosine and inverse tangent as well.